the gradient of y is equal to n. The gradient of y is equal to x raised to power n. X raised to power n. Now we are entering into a very important part of this topic. We are getting into a very important part of this topic, and that is how to differentiate. That's what we call differentiation. So for us to get the gradient of a function, y is equal to x squared plus whatever it is there, we need to know now how to get the gradient function of that function. Get the gradient function of that function. So to get the gradient of this line, of this curve, y is equal to x raised to power n. I want to explain some things here. X, let me call x is the base. We can have y is equal to 2x raised to power n. So I want to explain something here. In the first equation and the second equation, the things I wanted to mark here. The coefficient of x here is 1. We don't write 1x, but the coefficient here is always 1. So if this is the coefficient of x, and this x has a power, so let me say that this x is the base. This is the base, and this is the power. This is the base, and this is the index, which is the power. We have to get up to that point. So to differentiate, to get the gradient function of this one, we take the power and then we multiply with the coefficient. Take the power. I want to start with case 1 here. So y is equal to x raised to power n. This is the power n. I will multiply the power with the coefficient. What is the coefficient here is 1. So 1 times n I will get. So this one is called y. This one is equal to 1 times n will be n. And then x. And then the power n, you minus 1. Right? Then let me come to number 2. So when we do this, we have, this is called the gradient function. What we have here now is the gradient function. So don't worry, I'm just using the general one. We will do examples and we will be able to understand exactly what we are talking about. Next here, let me see here, case 2, we have y, or I can say dy over dx, that is the gradient function, which is equal to now, the power here is x, and the coefficient is 2. So the power multiply with the coefficient of x, so that will be 2n, and then the base x, you multiply with the base x, which is now n minus 1. So you subtract, what remains is the power minus 1. That's what remains. And this is now the gradient function. This is the gradient function of our number 2. That is the gradient function of our number 2. That is the gradient function of our number 2. Very nice. So what we have done is differentiation. When you find the gradient function of a function, you do what we call differentiation. So what is a differentiation? It's simply getting the gradient function of a function. Getting the gradient function of a function is what we call differentiation. Let me now do the practical example. Let me not use the y's and the whatevers, so that now you can be able. So given that given that y is equal to x raised to power 6 and y is equal to 3x raised to power 7. Now find the gradient function. Find the gradient function of y in both cases. So let's begin with A. So let me call the first one is A and the second one is B. If that is the case, then I will start with A. So y is equal to x raised to power 6. So if x is raised to power 6, then remember what we have said. The base here is x. The power is 6. The coefficient of x is 1. So there is 1 here yenye iwekwi. Unafaa kujua when you see x raised to power 6, there is always 1 here. So how do you differentiate? We differentiate y with respect to x. What do we mean by that? So we say dy over dx, which is the same as y raised to this power. The power this one. We negate y like this is the same as dy over dx. This one and this one is the same. So if you don't write the dy over dx and you write y like this, then that one means you are differentiating. So we multiply now, we take now dy over dx will be equal to the power times the coefficient. So 6 times 1, the answer is 6, right? And then now we write the x. What remains here is 6 minus 1 from the general differentiation we did. So what is remaining here is 6 minus 1. So the final answer, dy over dx of our first equation will be equal to 6x raised to power 5. And that is we have differentiated now. My part B, we have y is equal to 3x raised to power 7. So you realize that now in this case, our power is 7, the base is x, and the coefficient of x is 3. Rule number 1, dy over dx, because on the left side we have y, on the right side we have x. So we are differentiating dy with respect to x. Ndio maana tunasema dy over dx, which is equal to now 7 is the power, the coefficient is 3, so it is 3 the coefficient times the power, which is 7, and then x raised to power 7 minus 1. So this one is equal to this times this. Use your calculator if you don't know. 7 times 3 is 21. And then x, if you don't know, minus finger calculator, 7 minus 1, you realize that it is 6. So it means dy over dx, or the gradient function of 3x raised to power 7 is 21x raised to power 6. 21x raised to power 6. And we have done that one is called now. What we have here is the gradient function of those functions we have there. This is the gradient function. If that is fine now, we are moving on very nice, very well. And you are going to find this topic very interesting. Very interesting if you follow step by step. And the next thing we want to look at now. So what is now differentiation? The gradient function, what we have now there here, is called a derived function. What 21x raised to power 6 is actually a derived function. So the process of getting this derivative here, the process of getting the gradient function is what we call differentiation. Let me do now the function which has negatives. If it is, for example, let me go back here and delete this. Do more examples, because once you understand this one, mbele itakuwa rahisi, mbele itaenda kuwa rahisi. Given that y is equal to x, 2x raised to power negative 3. What if the power is negative? And y is equal to, let me use an example here, raised to power x, or we can use 3x raised to power negative a half. Whichever the case it is, it doesn't matter. With now this is a, and then we call this one is b. We use pink here. So solution. Remember, we start with a, dy over dx. Kwa nini tunasema dy over dx? What I'm going, okay, it is something, let me put something clear here. If I give you s is equal to t square, and then I ask you to differentiate. If we are differentiating this one, we are differentiating s with respect to t. So we are going to say ds hii ya kwanza venye tulikisema dy over dt is equal to, itakuja hapa 2t. So what I'm saying is, it depends what you are given on the left side and the right side. So dy over dx ni kwa sababu tumepewa the first value, the first variable ni y, the second variable is x. So we differentiate, that is dy over dx. If you are given like this, the first variable is s, the second variable is t, so we say ds over dt, which is this. Thank you, very important. So we come here, we go back to our a, we say that now dy over dx will be equal, our power, our index is negative 3, our coefficient is 2, the coefficient of x, so we start there. 2, the coefficient of x, times negative 3, correct? Then x, right? Minus 3, the power, minus 1. Because the rule is, you subtract 1 from the power, you multiply the power with the coefficient of x. That is the rule which we must follow. That is the rule which we must follow. Then, once we are there, if you have a problem with now, this is where now Form 1 comes in. Like I told you in the first introduction video, is that mathematics depends on the knowledge you have learned previously. But nowadays I was saying that it's good, we thank God that the calculator is there. If you do have a problem with integers now, use your calculator. The calculator is very well programmed that it will give you everything that you need. Here now, just press your calculator. 2 times negative 2, you will find that the answer is negative 6. Our x, and come to the power. Take your calculator, press negative 3, negative 1, and press answer, equal sign. And that one will give you negative 4. And we are done. So this one is dy over dx. Dy over dx. And that is our gradient function. Good? Yes. Next. Part B. We are doing part B. Our part B is here. First, identify the power. Identify the coefficient of x. Rule, simple rules, please. The power is a negative half. The coefficient of x is 3. We started there. So we are going to say dy over dx is equal to the power negative 2, negative half, times the coefficient of x, which is 3. After that, you put the x, which is the coefficient, the base, and then now the power is negative a half minus 1. That is the rule. It remains. Take your calculator, press negative 1 over 2 times 3. You will realize that the answer will be negative 3 over 2. And then x, negative 1 over negative a half, negative 1. The answer should be negative 1.5. So the answer should be negative 1 and 1 over 2. As simple as that. And what we have here is the gradient function. This is the gradient function, dy over dx. The gradient function. We are moving very well. Now I want to talk about the gradient function of polynomials. The gradient function of polynomials. The gradient function of polynomials. That's the next thing. Let me delete this one, that we can have a clean black whiteboard to work on. Now we are at the gradient function of a polynomial function. A polynomial function is a function which has got more than 2 terms. So that's what we call a polynomial. So without wasting much time explaining, let me use an example. An example of a polynomial is y is equal to x raised to power 3 minus 2x raised to power 2 minus x plus 4. This is a polynomial function, right? This is what we call a polynomial function. How do we differentiate a polynomial which has got more than one? So tumefanya hii, tumemaliza pande hii. Hii tulikuwa tunafanya it has only one term. It has one term only. So now we have a polynomial which has more than 2 terms. So this is the first term, second term, third term, and this is the fourth term. So this function has got 4 terms. To get the gradient function, we differentiate each term separately, right? We differentiate each term separately, considering the mathematical hii kama mbele yake kuna positive na negative. Kuna jina inaitwa imepotea. So how are we are going to differentiate this? Very simple. If you have understood what we have done, it is going to be very, very much simple than you thought. It's going to be very simple than you expected. Let me use red or blue to differentiate. So here, ukiangalia, we have y with respect to x. That's now we are going to say that dy, we are going to say dy over dx is equal to this one. The first term, the power is 3, the coefficient is 1. So it will be 3 times 1, the coefficient, and then x, 3 minus 1, which is the next one. The next one, the coefficient is 2, the power is 2. So we are going to have 2 times 2, and then x, 2 minus 1, minus this one, x, the coefficient is 1, and the x is 1 minus 1, because now the power is 1, so 1 times 1. Okay, I'm changing something because I want to make it very slowly and very simple for all of us. So there's something I want to mark for you here. If I am given x ikiwa namna hiyo, empty like that, it means it has power 1. We don't put it there. Mathematically, there is a power there, 1. So this 1, there is another 1 here, right? So 1 here, there is 1 times 1, and then x, 1 minus 1, and then plus 0. Why did I put 0 where we have 4? 4 does not have x it doesn't have the x. So if it does not have x, because we are differentiating y with respect to x, any term which does not have the x is as good as 0, is as good as nothing. Did you hear that? I said a term in a polynomial which does not have the, if it is the x, if we have dy over dx, if there is no x in that number, then it is as good as 0. When you are differentiating, it is 0. Tafadhali understand that. I want you to understand that. So let's now finish up. This one is the same as now. 3 times 2, 1, the answer is going to be 3x 2 minus 4x 1, we don't write 1, minus 1 times 1 is 1, and then x, 1 minus 1 is 0. So a number raised to power 0 is 1. So x raised to power 0 is 1. So 1 times 1 is 1. And that is the gradient function of that polynomial. So dy over dx is equal to this, and this is the gradient function of this polynomial. The gradient function of this polynomial is this. Very, very nice. Very good. We are moving on well. We are moving on very well. Let me clear this. And then do 1 more 2, 3 examples again, so that we can be able to understand it very, very well. Very, very well. So let me now use a different. Find the gradient function. Find the gradient function. Or somebody can ask you, find the derivative function, the derived function. So derived function and the gradient function is the same thing of each of the following. Of each of the following. Find the derived function of each of the following. Number 1, number A, I will start with s is equal to 2t cubed minus 3t squared plus 4t. And then number B, let me write B here. We have 4 over 3 pi r cubed. And then number C, we have A is equal to v squared plus, minus 2v plus 10. Right. So let me start with A. Let me start with A. Now here, solution, our solution. A, we have s with respect to t. So we are going to say that the gradient function, so instead of telling me the gradient function, just write dy over dx. We know if you write dy over dx, that is the gradient function. So there's no need of, in mathematics, we are not writing notes. What we are is the concept. What do you know? What do you know? So the gradient function is given by d. Now this is ds over dat, because we are differentiating s with respect to t. Now this one is going to be, the coefficient is 2, the first term, the power is 3. So that is 6t squared. Now you understand what I'm doing. Minus, the power is 2, the coefficient is 3. So that is 6t. 2 minus 1 is 1. and then plus 4t, that is going to be 1 times 4t, that is going to be 4. And that is the gradient function for the first one. The second one, b, we are going to differentiate. Oh, what was the I have just copied wrong. It is v. V is equal to, sorry, this one is supposed to be v is equal to 4 over 3 pi r cube. 4 over 3 pi r cube. Now this one, we have v, which is equal to 4 over 3 pi r cube. So this one we are going to differentiate, or to get the differentiate v with respect to r and not pi. So here the v, because in the variable on the left side is v and the variable on the right side is dr. So meaning we are going to differentiate v with respect to r only. So in animation on the right side, we consider the power of r only. So this one is the same as, so the power is 3, so we are going to have 3, which is the power, times the coefficient, which is 4 over 3, and the pi, and then r, 3 minus 1. So finally the answer here is going to be v over dr is going to be 4 pi r square, and that is the what we have in our differentiation there. The last one, c, we are given that va is equal to v square minus 2v plus 10. So here we have a with respect to v. So we are going to say the gradient function is going to be dA over dV. dA over dV is going to be, the power is 2, the coefficient is 1, so that is 2v minus, the power here is 1, 2, so that is 2. And this one is 0. And this is this, because it doesn't have v, then if there is a term which has no v, because hapa tunatumia v, kama 10 haina v is as good as 0, so we don't even consider that during differentiation. So the gradient function here is 2v minus v minus 2, as simple as that. So having understood that, now we move ahead to a very important critical moment. Very nice. Very, very important. Let me clean the whiteboard, and then now we move forward to a very important thing now. We have talked about the derivative. Now we want to find the gradient of a function of a curve at a given point. Very nice. The gradient of a curve at a given point. So here we are going to be given a point, and we are going to be given a curve. Y is equal to blah 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 at the point 2, 3, at the point negative 1, 4. So point negative 1, 4 is the point, and the curve you will be given. So to do this, to get this one, is a very simple task for us to do. Very simple task. So for example, I like using examples to explain things which are important. So I will use an example. Find the gradient. Find the gradient. Find the gradient of the curve y is equal to x square minus 3x plus 2 at a point 2 comma negative 2. Very important. So I'm going to do this one example and finish for those that I'm going to do one example only. So you need to be very attentive of what we are doing. So we are looking for the gradient of a curve at a given point. The gradient of a curve at a given point. Solution. Let me give you the rules to follow here. If you have the gradient curve and you have a point, you need the gradient at that point. Now here we need the gradient a number 2, gradient is equal to 3. Hivyo tunataka gradient. Rule number 1, get the gradient function. So let us start by getting the gradient function. The gradient function you differentiate. So let us differentiate. So our y is equal to x squared minus 3x plus 2. Therefore, dy over dx, and that is the gradient function, will be to x minus 3. Hii tu ya mwisho ni 0 because haina x. So our gradient function is 2x minus 3. Then you say at the point 2 comma negative 2, the first coordinate is x, the second one is y. So at this point, the x coordinate is 2. We substitute in our gradient function and find the gradient. So the gradient is equal to 2x minus 3. And then now 2 into 2, hii 2 nimetoa wapi? Ni value at this point. The gradient, the value of x is 2, and then minus 3. So that is 2 times 2, which is 4, minus 3. So the gradient of that curve at that point is 1. 4 minus this. So the gradient is 1. So kitu ya kwanza, acha nieleze kwa Kiswahili. Unatafuta the gradient function, tushaelewa. Ukishapata the gradient function, ile point ambayo umepewa, unaangalia the value of x at that point. So kama hii point yetu ni 2, negative 2, the value, the coordinate x ni 2. Una substitute hiyo 2 mahali uko na x kwa gradient function. Unapata the gradient at that point immediately. Maybe I do one more. If I have y is equal to 3x squared minus 2x cubed minus plus x squared plus 4 at 0.5. So find the gradient. Like to make the question will be the same. Find the gradient. So rule number 1, differentiate. Dy over dx itakuwa nini? Itakuwa 6x minus 6x2 plus 2x na 4 itakuwa 0. So hii nimepiga the power times this ni 6, ikabaki 1. The power is 3 times 2, 6 minus ikabaki 1. The power hii ni ikaanguka hapa ikakuwa 2 times 1, ikabaki 1. And the 4 is 0 because it doesn't have x. Haina x. Now at, this is the gradient function. So what we have here is the gradient function. The gradient function is this. Now we at, then you say at 0.4. At 0.4, the gradient itakuwa nini? So you take 6, you substitute with the value of x here. So 0 minus 6 into 0 plus 2 into 0. So the gradient is equal to 0. At that point, the gradient is 0. Allow me to move forward and do a different question now. At what point is the gradient? Very good. Now we are going to use the gradient and to find a point. Here, like this one, we were given the point. We were given the point 2, 2. So I want us to do the reverse of this question. And our final answer should be 2, negative 2. I want to use this one and do. So at what point I'm going to use this question so that we are going to calculate this point 2, negative 2. Ndio tunaenda kutafuta. Ukijua kuenda shule kutoka nyumbani, lazima ujue kurudi kutoka shule ukirudi nyumbani. So when we have found the gradient is equal to 1, we can as well use the gradient 1 to get this point. Very important. So let us do that. Let's do that. Find the point at the curve y is equal to x squared minus 3x which one did I use here? This one was, oh, there was 2 here. Okay, no problem. 3x, x squared minus 3. I find the point at which the curve this, the curve that, at what point is the gradient? Find the point at this curve this, where the gradient is 1. Where the gradient is 1. So we have been told the gradient is 1. We want a point. So rule number 1, solution number 1, find the gradient function. Find the gradient function. Then number 2, equate the gradient. The dy over dx is equal to the gradient given. That will give you the value of x. So let's go and let us do it now. So let me change the color here. Use blue. So solution. So dy over dx, which is our gradient function, will be equal to 2x minus 3. And this one is the gradient function. So 2x minus 3 will be equal to 1. We are intended now to find the value of x. So 2x minus is equal to, take this on the other side, it will be 1 plus 3. So 2x is equal to 4. So it means that we divide by 2 here, and the value of x is equal to 2. So now we have the value of x. A point inafaa ikuwe na x na y, kwa ndio itwe a point. So tumepata the value of the point at x. But now we want y. Where do we get now y from? Tunarudi kwa equation. Equation yetu ilikuwa y is equal to x squared minus 3x. Sasa hapo ndio tunatoa y. But our x is 2. So anywhere you have x in the equation, you substitute with the 2. So y is equal to 2 raised to power 2 minus 3 times 2. So y is equal to 4 minus 6, and this one is negative 2. So our point where the gradient is 1 is equal to 2 comma negative 2. Now you see we have come back to what we were in the initial. So nimesema ukijua kuenda mtoni ni vizuri ujue kurudi. So that's how we get the point when we are given the gradient. And when you are given the gradient, you should get the point. When you are given the point, you should get the gradient. Very nice. I think we are doing well. We are doing well. That's good. The last thing I want us to do there is now to find the value, to do one example of a different So we are saying now, at what point that when we have done, when we have the gradient. Now one more example is there is an example I want us to do. I can't see it. Number 5, number 6. Anyway, I can't find it that, but at some point we are going to get it. So let us now look at the equation of the tangent and the normal to the curve. The equation of the tangents and normal to the curve. To a curve. Let us use article A, to a curve. So I want to explain something here, and we did explain initially. We are talking about a curve and the tangent. So let me draw a Cartesian plane. And I am going to draw a curve on this. So I have this curve. Y is equal to 2x squared plus 4x plus 2. And assuming that is my curve, I want to explain the tangent and the normal. Now this is where I was talking the relationship between form 2 work and the form 4 work. You are going to see how we are going to apply the knowledge in the first video. Here, now I want to draw a tangent at any point. So if I take this one as to be my point and draw a tangent there, and draw a tangent there. So a tangent is a straight line. That is a tangent. This one is what we call a tangent. I have drawn a tangent from the curve at this point. Let me call that point A. So the normal to the curve, to the tangent, the normal is a line that is at that point which forms a perpendicular. So this one is the normal because it forms 90 degrees. So the tangent and the normal, this is the normal, they are perpendicular. They form 90 degrees at that point where they meet the curve, right? But we know that the gradient of the curve will be equal to the gradient of the tangent. So we will calculate the gradient of the curve which will give us the gradient of the tangent. From the gradient of the tangent, because it is normal, it is perpendicular to the normal, we will get the gradient of the normal using the perpendicular relationship gradient in form 2. Right? Now that is the point. That is the point. So let me go into the question and do an example so that we can understand even better. Example 1. Find the gradient. Find the gradient. Find the gradient. Find the gradient of tangent. Find the gradient of the tangent to the curve. Find the gradient to the curve y is equal to x cubed plus 2x plus 1 at 0.1, 4. Very good. So the point at the curve is 1, 4, where the tangent was drawn. Mahali walichora hiyo curve. So assuming hii, let me just explain something here. So assuming this is a Cartesian plane, this is x and this is y. So mahali walichora hii y hapa, hii point hapa ndio tutakuwa na 1, 4, that point. So where the tangent is drawn here is where we are for. So the normal itachorwa na ipitie pale. So the normal and the tangent passes through the same point. So they share that point. Understand that place. The normal and the tangent, at that point they have the same point. That's 1, 4, because they meet there. That's where they intersect. Nice. Maybe. So solution. Solution. Rule number 1, because we are looking for the gradient of the curve. Remember, the gradient of the tangent is equal to the gradient of the curve. So we started by getting the gradient of the curve. And how do you get the gradient of the curve? Is to differentiate and then substitute with the value of x. So gradient is given by dy over dx. Then we are differentiating, which is going to be 3x squared plus 2. And that is the gradient function. But at 0.14, the value of x is 1 and y is 4. So we don't bother with y, we substitute to get, so gradient is equal to 3 into 1 square plus 2. I am substituting the value of x in our gradient function. So it means that the gradient is going to be 3 plus is going to be 5. That is our gradient. So the gradient of this line is going to be 5. So next, now we have the gradient of the curve. So remember, the gradient of the curve is the same as the gradient of the tangent. Therefore, the gradient of the tangent is equal to 5. The gradient of the tangent is equal to 5 because the gradient of the curve is equal to the gradient of the tangent. Now, what will be the gradient of the normal? Because the normal, now we know the gradient, so the tangent we know. is 5. Then it means the gradient of the normal is equal to -1/5. So that when we multiply -1/5 times 5, the answer is -1, because perpendicular lines M1 times M2, the answer should be -1. For perpendicular lines, because the normal and the tangent, they are perpendicular. When we multiply the gradient of the tangent and the gradient of the normal, the answer should be -1. So that is -5 times -1/5, 5 times -1/5, the answer is -1. Find the equation of the normal to the curve y is equal to x cubed minus 2x minus 1 at the point 2 minus 2. So that is the point. Now remember, this one is a 3 marks question. Rule number 1, you need to get the gradient of the tangent. And you should remember that the tangent and the normal, they are perpendicular. Now that is the knowledge. Now see the way we are going to do it. So first, let us get the gradient function. So dy over dx is equal to, let us differentiate this one, tutapata ni 3x square minus 2. And that is the gradient function. But at 2, -2, at this point, this is the x and this is the y. So we substitute the value of x inside here in the gradient function and get the gradient. So the gradient of the curve, will be equal to 3, 2 raised to power 2 minus 2. This one is 3 times 4, which is 12, minus 2. 2 raised to power 2 is 4. 4 times 3 is 12. And this one is going to give us 10. So the gradient of the curve is 10. But that gradient is the same as the gradient of the tangent. So the gradient of the tangent at 2, -2 is equal to 10. Remember, we know Podolsky does to calculate the gradient of the tangent, but we need it. It is the thing we need for us to go to the normal. So since now we know that the normal and the tangent, they are perpendicular, we know that if this is the tangent, then the normal is this way. This will be the normal. So if we know the gradient of this line is 10, then the gradient of this one should be -1/10. Now that is the relationship we are talking about. So the gradient of the normal is 1/10. Now next we say the gradient of the normal is 1/10. Now we have the gradient, we have the point where they meet or they intersect at 2, -2. How do you get the equation of a straight line? Because a normal is a straight line, as you can see. So we have the point and we check the general point x and y. Now this is the knowledge I have taught in the first video, form 2 work, and this is very important. We know that the gradient is equal to change in y over change in x. We have 2 points, we have xy and 2, -2. So y minus -2 over x minus 2, the answer should be negative 1 over 10, which is the gradient of the normal. Now from here, we cross multiply. So let us cross multiply. But remember that a negative times a negative here becomes positive. So we will have 10 into y plus 2, which is equal to negative 1 into the x minus 2. So this is 10y plus 20, which is equal to negative 1 times x is negative x. Negative 1 times negative 2, the answer is positive 2. You will not calculate negative 1 times negative 2. The answer will be positive 2. So from there, you like terms together, we will have 10y is equal to negative x. Bring this 20 from the left side, ivuke equal signs ikuje to the right side. So this one, ikikuja hapa, inakuwa positive, inakuwa negative because hapa iko, so that one plus 2 minus 20. So 10y is equal to negative x. 2 minus 20, the answer should be minus 18. So this equation is okay, so because you have not been given any instructions. Kama hujaambiwa, the equation should be in the form of y is equal to mx plus c, then you can leave this equation here. But if you are asked to write the equation in the form of y is equal to mx plus c, the general formula of a straight line, then you divide by 10 every term. Divide by 10 here, divide by 10 here, divide by 10 here. So we'll have y is equal to 1 over 10x minus 10 over 18. And that is all you need to know. I think that one I have emphasized enough. Now let us move ahead and do another example that you might challenge you. There is one example I'm going to do here that might be a challenge, but I want to remove that fear here right away. And this is the question I want to do. Find the equation of the tangent find the equation of the tangent to the curve y is equal to x cubed minus 2x square minus 1 when y is equal to negative 1. So you can see this one is very different from what we have been doing. So how are you supposed to handle this? Here you can see we have been given y. We don't have x. So then the first thing you need to get is the value of x. How are you going to get the value of x? Solution. So let's find the value of x. So, but y is equal to x cubed minus 2x squared minus 1. But y is equal to negative 1. So we substitute here, we say negative 1 is equal to x cubed minus 2x squared minus 1. Like terms together. So this one comes here and 0 remains here. So 0 is equal to x cubed minus 2x squared minus 1 plus 1. Yes, so negative 1 plus 1 is 0. So we are going to have that x cubed minus 2x squared equal to 0. Now we want the value of x. Ukiangalia x cube na x square, the common factor is x square kwa sababu x square iko ndani ya x cube. So the common factor is x square into, kwa x square imebaki x moja minus 2. X square ndio hii, so inamaliza is equal to 0. So inamaanisha hapa x square is equal to 0 or x minus 2 is equal to 0. So x is equal to 0 or x is equal to 2. So hii ukienda pande hii ikikuja huku inakuwa positive. So tumepata the value of x. Umeona? Tumepata the value of x. So we continue. There's no need of underlining. So remember the question was asking us to do what? To find the equation of the tangent. So it means now what we have the point. We have the point which could be 0, negative 1 or 2, negative 1, because the values of x is x tumepata ni mbili, 0 or this one. Tumeelewana? And now what we need is the gradient. We need the gradient to get the equation. Now the gradient function is given by dy over dx. Now we will go back to our y. Our equation is y. Let us get the gradient function here, which is equal to, differentiate this one, itakuwa 3x square, right, minus 2, that is 4x, like that. So when x is equal to 0, you see that the gradient is going to be 0. Umeona? And then when x is going to be 2, the gradient inaenda equal to, substitute hapa itakuwa 3, 2 square minus 4 times 2. So gradient itakuwa 12 minus 8, itakuwa 4. The gradient will be 4. Now here we will have two equations. When x, the gradient is 0, and when the gradient is 4. So let me do one, because you need to do 2 times. So the equation of we have the gradient 4 or 0. We can use them. Now we have the point 2, negative 1, and point 0, 1. Use any of them. So we can start with, I will ignore the one for the 0 and do, but in an exam you need to do both. So let me show you how to get the gradient. Lakini tushafanya, so, but I will just do it. Now we have the point, we have the gradient. So we will say the gradient is equal to change in y over change in x. When x is equal to 2, so we are going to say y is equal to, y minus the point minus 1 over x minus 2. We are going to have the gradient, which is 4, right? And so now utapata gradient, and then we say when x is equal to 0, hapo utapata the equation. Tumemaliza. And for when we say when x is equal to 0, utasema y minus 1 divided by x minus 0, and the answer is 0. And this one, the gradient, actually the equation is going to be, everything is 0, is going to be y plus 1 equal to 0. Hiyo ndio equation ya when x, the gradient is 0. As simple as that. I hope umeelewa kenye nimefanya. I hope you have understood what I have done here. And then one more last example here. One last example is when last example in this subtopic is find the point on the curve. Find the point on the curve y is equal to x square minus 3x plus 7, at which the gradient, at which the gradient is 5, and the equation of the tangent and the normal at this point. So we have to find the equation and the equation of the tangent and the normal at this point. So hapa tuko na kibara. We have work to do here. We need to get the point. After getting the point, because we have the gradient, now we are going to use the point to find the equation of the tangent and the equation of the normal. The equation of the point should be very simple and fine now. So let me take you through that very fast. Solution. So we have the, let us get the gradient function. dy over dx is equal to 2x minus 3. Was it 3 square or I made a mistake? Yeah, it is okay. It is 3x plus 7. So our gradient function is this, but this function is equal to 5 because we have the gradient. So we want the value of x. So here we are going to say 2x is equal to 5 plus 3, right? So we are going to say that 2x is equal to 8, and the value of x we divide by 2 is going to be 4. Now the next thing, a point, it has to have the x coordinate and the y coordinate. Now we go back to our equation, y x square, so we substitute, so y is equal to x square minus 3x plus 7. So our x is equal to 4. We substitute, so y will be equal to 4 square minus 3 times 4 plus 7. So this is 16 minus 12 plus 7. So 16 minus this is, okay, we can press the calculator. This is 4. So y is equal to 11. Y is going to be 11. So the point will be 4 the x and 11 the y. Tumepata the point. Now we have the point and we have the gradient. So what is difficult to get the tangent? We are going to do that. Nothing is going to be now difficult for us to get the tangent and the normal equations. So for the tangent, we have, for the tangent, equation of the tangent, we have the point 4, 11. We have the gradient of the curve, which is 5, and it is the same as the gradient of the tangent. We have the general point, x, y. So we are going to say gradient is equal to change in y over change in x. So that is y minus 11 divided by x minus 4, which is equal to 5. So we close multiply. We are going to have y minus 11 is equal to 5x minus 20. So finally, y is equal to 5x. You take this on the other side, itakuwa minus 20 plus 11. That one is going to be minus 9. And that is the equation of the tangent. Now the normal, if the gradient of the tangent is 5, then the gradient of the normal is equal to -1/5, such that 5 times -1/5, the answer is -1, perpendicular, because the normal and the tangent are perpendicular. Now we have the gradient of the normal, we have the point 411 and the xy. Sasa hiyo itakushinda kupata the equation, repeat what we have done here. So you are going to say gradient equal to change in y over change in x. So utasema y minus 11 over x minus 4, because they are sharing this point. They intersect at the point 411 is equal to -1/5. Please cross multiply and get the equation. Thank you, very important. Thank you very much. Stationary points. Stationary points. Kindly subscribe, like, share. Thank you. On a curve, we have, let me assume this is our curve, and we have another curve like this. So this curve has this point here. This is the turning point here. The turning point, yani mahali inageukia, the turning point. This is what we call the turning point. For this one, the turning point is here. So this one is the turning point or a stationary point, and this one is the turning point. These are what we call the turning point of a curve. So at the turning point, the key word here is that at the turning point, at the stationary or at the turning point, the gradient function of that curve, of the curve, is equal to 0. That is the key word. At the stationary point, at the turning point, the gradient function is equal to 0. Mark that and know that. If that is the case, then we have two types of turning point. One, we have the maximum, and we have the minimum. So we have the minimum point and the maximum point. So the first one here is the minimum point, and this one here is the maximum point. So you realize that the maximum, let me use this table here. If this is the stationary point, stationary point, if we have maximum, then the gradient starts with a positive. The gradient here function, the gradient to the left. We are going to talk about this, and then gradient at the stationary point, that is dy over dx, then at the positive, so gradient to the right, and then the nature of the, so there is a table here I'm going to draw. So when we have the maximum point, we are starting here onto the left, we have positive. This one is a 0, this one is a negative, and the nature, so positive, we go from a point up, 0, and then down, negative. So that is then the shape or the diagrammatic representation for the maximum. So the is above, the turning point equal juu is on the top. That is the maximum turning point. Let's talk about minimum. What about the minimum? For the minimum, starts with negative, then 0, positive. So let's see, this is a negative, so it comes down. The negative is coming down, down, 0, up, positive. This one is the minimum. So this diagram represents the minimum, this diagram represents the maximum. Then if we come from negative to positive to 0 and then positive, that one we have the point of inflection. This one is the point of inflection. That is not the turning point, it is a point of inflection. If we have negative, 0, then negative, then that is not the turning point, it is the point of inflection. It is the point of inflection. So how does the point of inflection? So we start here and positive, we go up, positive, 0, then up. That is, what is negative? We start at a point down, 0, down. That is the point of inflection. So this and this are point of inflection. This is the minimum, this is the maximum. So this one, we are going to make use of them very, very soon. One more important thing I said is that at the stationary point, at the turning point, remember the gradient function is 0. Very important. So we are going to use that knowledge to do some maths here. Let me use an example for you to understand even better. Identify the stationary point. Identify the stationary point. Identify the stationary points. Identify the stationary point on the curve. On the curve y is equal to x cubed minus 3x plus 2. For each determine the maximum, determine whether it is maximum or minimum. For each determine for each determine whether whether it is the maximum, minimum, or point of inflection, or a point of inflection. So this question contains 10 marks. This question contains 10 marks. That's paper 1. We expect a question of this nature, paper 1, section 2, section B, or section 2. So let's see where we start. We need to understand it by getting the gradient function, because we know at the stationary point, dy over dx is equal to 0. That is the key word. So at the stationary point, dy over dx is equal to 0. So let us get the dy over dx. So our dy over dx is equal to, we integrate this, we differentiate this one, we're going to get dy over dx is equal to 3x squared minus 3. But we have said at the stationary point, dy, that is 3x squared minus 3, the answer should be 0, right? Because that is the keyword. At the stationary point, dy over dx is 0. So you can simplify this and get the value of x. We want the value of x. As you can see, this is a polynomial. We are going to get 2 values of x. So we can, 3 is common, so 3 into x square minus 1 is equal to 0. X minus 1, because it's a difference of 2 squares, x plus 1. So you can see here, x is equal to 1, or x is equal to negative 1. But that, okay, the value of x itself is x is equal to 1 or x is equal to. This one is just say, e is 3, 3 is equal over 0 is 0, so that's nothing there. Then, now our value of x is equal to 1 or x is equal to negative 1. So we need to find now the point, the stationary point. To get the stationary point, we have the values of x. How do you get a point? You take the values of x and substitute on the function. Our function is y is equal to x cubed minus 3x plus 2. So when x is equal to 1, what will be y? Substitute here. We are going to have 1 minus 3 plus 2. And that one is minus 2, so y is going to be 0 there. When x is 1, y is going to be 0. So the stationary point there will be 1, 0. That is the first stationary point. We will have 2 stationary points because we have 2 values of x. Next is when x is equal to negative 1. When x is equal to negative 1, we substitute there again. So that one will be negative 1 cubed minus 3 minus 1 plus 2. So this one is going to give us y is equal to 4. So we'll have x. The another point we are going to have is 1, negative 1, 4. So now we have 2 stationary points. The next, now the last thing is to want to determine between point 1 is 0, and negative 4, 1, negative 1, 4. Which one is the maximum? Which one is the minimum? Or which one is the point of inflection? That is the next thing we are doing. Remember, I told you this is a 10 marks question. So we go to part B, because this question will be divided to part A, B, like that, but now we are doing it generally. So to determine which stationary point is maximum or minimum or point of reflection, we are going to draw a table like you can see here. Let me open here. We are going, so at when at the stationary at the point -1, 4, we want to check whether this one is maximum or minimum. So you draw a table. You draw a table. With the 3, and then it is a simple table where we have the value of x. The next one is dy over dx, and the next one is the diagrammatic representative, that is the nature of the shape. Then make sure you have 3 columns like this, right? So the 3 columns we have at the middle. So we have the value of x here. Our value of x, our x here, we are considering this x is equal to -1. So we put that value at the center of these 3 columns, 1, 2, 3. So tunachukua our -1 here, the value of x. So umeona hapa ni x, hapa ni x. So the x here, our x tunaiweka katikati, tumetengeneza to the left and to the right. Kuna kitu tulikuwa tunafanya hapa left and the right, katikati ni we had the gradient. You are going to see that the gradient, the dy over dx is always going to be 0. Yeah, sawa. Now here, find any number to the left of -1 and another number to the right of -1. So a number to the left of -1 is -2. A number to the right of 0 is to the right of -1 is 0. So you should know the number line. Here unafaa kujua the number line. Now, the next thing is you substitute these values in dy over dx. Our dy over dx ilikuwa, nini? Ilikuwa 3x square minus 3. Kwa hivyo tunaanza na -2. Substitute. Mahali unaona x unaweka -2. So tunasema 2 -2 square minus 3. This is 2, that is 2, 4 times 2, 8, 8 minus, so this one is going to be 5. This is 3, sorry. This is 3. So, negative, that is 12, 12 minus 3, that's 9. We are going to have 9. So here is 9. If you substitute with -1 here, the answer is going to be 0. Here the answer will always be 0. And then we put it there. If we put this 0 here, the answer is going to be -3. So you substitute for 0, you unasema 3x, which is 0, minus 3. That is the answer. So now the nature. How are you going to draw the nature? Hii ni positive. So ikiwa positive unaenda juu. So positive inaenda hivi. 0. Hii kwa sababu imepanda, itakuwa hapo juu. Halafu hii inateremka. Unaona? Now this, the nature, the diagrammatic representation for this one will be this, this, this. Meaning that point -1, 4 is the maximum. Now we repeat the same using now the point -1, 0. We do the same using that point, that one. So from there, now I can delete this one. Good. Now we're at the point when the point is 1, 0. We at this point, the value of x here is 1. So hapa kwa hii column 1, 2, 3, at the center weka the value of x, tutaweka 1. Then find one number to the left of 1, that is 0. One number to the right of 1, that will be 2. Right? Now substitute these values of x, these are the values of x, on the gradient and get. So if you substitute here 0, the answer is going to be -3. At the middle, the answer will always be this 0. dy over dx, if you put here 1, itakuwa 3 minus 3, the answer is 0. Next, when x is 2, itakuwa 3 into 2 square minus 3. Itakuwa 12 minus 3, and the answer is 9. This is 9. So the nature will be, so ukiangalia hii ni negative, so negative inateremka 0, alafu positive inapanda. So this one is this, this, this. Then it means that then it implies that point 1, 0 is the minimum. And that is how you score your 10 marks up to that point. Up to that point, umescore marks yako 10, and you become happy when you get that one in an exam. So that's how simple it is. It is very simple. It needs practice. You do a lot of practice on it, and then it becomes part of you. You know, when you write, that's the reason why we ask you to do a lot of practice, because there's a connection between your fingers and your brain. There's a connection. When you practice a lot, everything becomes easy to an extent. So maybe I will do another example. Another thing in this topic, in this subtopic of stationary points, you need to understand very well how to solve quadratic. You can use the formula or the factor method. You need to know now the knowledge in Form 2 of using the factor method to get the values, or you use the Form 3 quadratic formula to get the value of x, because you will need to have the two values of x, right? So let me do another example. Identify the stationary points. Determine the stationary points on the curve y is equal to 1 plus 4x cubed minus 4 minus x4 minus x raised to power 4 x raised to power 4. determine the nature of each stationary point. Determine the nature of each stationary point. So this sum carries 10 marks. First thing, you differentiate, you get a gradient function. You equate the gradient function with 0. That helps you to get the values of x. They can be 2. Once you get the 2 values of x, so it depends, they can be 1 or 2. So it depends how the question has been set. But mostly you will get 2 values of x, where one could be the maximum, another one the minimum, or one could be the maximum or minimum, another one a point of inflection. So that is the nature. So the nature, you are going to say this point is maximum, this point is point of inflection, this point is the minimum. That is what we call the nature. So the nature, you are going to determine whether it is maximum, minimum, or the other way. So let us look at this one very fast. Let me use this solution. So first let us find dy over dx. Dy over dx will be, this one will be 0. So 3 times 4 will be 12 x square minus 4x cubed. That is our gradient function. So we can see x square is common. So we can say x square into 12 minus, in fact, 4x square is common. So 4x square is common. So hapa itakuwa 3, itabaki 3 minus x is equal to 0. That's very nice. So it means x is to be 0. So because this has got a value of x, 4x squared divided by this one is going to be 0. So x, 4x squared is equal to 0, or 3 minus x is equal to 0. Fine. And then it means here x is equal to 0, and here x equal 3 minus x. X is going equal to x is going to be 3. X is going to be 3. So these are the two values of x. Once we have the values of x, the next thing we need is the values of y, because we need points. A point should have x and y. So you bring the equation down here and say y is equal to 1 plus 4x cubed minus x raised to power 4. So you say when x is 0, so y will be 1. So when x is equal to 0, here you substitute, this one will be 0 minus 0. So y itakuwa 1. So the point itakuwa 0, 1. That is the point. Next, when x is 3, when x is equal to 3, so y itakuwa nini? Itakuwa 1 plus 3 into 3 cubed minus 3 raised to power 4. Right? And this one will give us this is 27 times 3, 81. That is one. This one is going to be 28. So the point now, the point will be x, which is 3, 28. Now, the last thing, we want to determine whether this point, we want to determine that this point, let me call it B, and this one, let me call it A. We want to determine whether A is maximum or minimum. We want to determine B, whether it is maximum or minimum, or inflection, in the point of inflection. That is the last thing you need to do. Well, how do you do that? You draw a table of this nature. Maybe I can draw it again, but there's no need. I can delete this. So you can delete everything up there. So you draw, when you are checking the nature, you draw 3 columns, 1, 2, 3, 4 columns actually. The first one you will have the value of x, the first one will have x, and then the second here will have dy over dx, then last one is nature. And this one you should have 3 columns, 1, 2, 3. Ile ya katikati ndio tunaweka the value of x. So tunaanza na when x is 0, we add 0, with a point 0, 1. So here the value of x is 0. So ile tunaweka katikati hapa ni 0 hapa. Sasa tafuta one number to the left of 0, one number to the right of 0. Number to the right of 0 is 1. To the left is -1. Now write down our function gradient. The gradient was, the functional gradient was 12 x square minus 4 x cube minus 4x cube. So if you substitute 0 here, everything is going to be 0. And even here, everything is going to be 0 there. Now let's put 1. If we substitute with 1 here, we will have 12 minus 4. And here is going to be 8. Right? To the left, we substitute here with negative. So -1 square is 1 minus. So in fact, it's going to be 12 plus 4. And this one will be 16. So the nature now, 16 is positive, so inaenda juu. O ni 0, so inakuwa, kwa sababu imeenda juu, so hii 0 itakuwa hapo juu. 8 bado ni positive, so itaenda juu. Umeona sasa? So this one is this, and that is a point. So you say O01 is a point of inflection. So we are remaining with the 2 marks to check for the other one. So the 2 marks is to check the other point. The other point was 3,28. That is the one we check tuone kama ni maximum ama ni minimum na tupate marks yetu 10. So let me delete this one here. In inside here, you clear everything because they are not going to be the same. Everything is unique here. So our value of x in this one, when the point is 328, our x is 3. So hii ya katikati sasa ndio utaweka 3, the value of x. After doing that, tafuta namba moja yenye iko left ya 3 and another number which is right of 3. 3 tunakitoka 3 tunaenda 4. So hapa weka 4. Before tufike 3 tunatoka 2. So that is the number to the left of. So once you have done that, if you substitute 3 here, This is going to be 9 times this, and the answer is going to be 0 here. That one, be sure. That is going to be dy over dx kwa x itakuwa 0. Now next, we substitute with 2. So unasema hapa 12 into 2 square minus 4, 2 cube. So 2 square ni nini? Ni 4. 4 times this itakuwa 48 minus. This is 8. 8 times this itakuwa 32. So 48 minus 32. Sini 16, one is going to give us 16. So ni calculator hii itakuwa 16. So hapa itakuwa 16. Now to the right we have 4. So we substitute here. So itakuwa 12. When it is 4, tunaenda kuweka 4 hapa. 4 square minus 4 times 4 raised to power 3. So this one is going to give us, you press your calculator, it will give us negative 64. So this is negative 64. Now let us draw the nature. So this is positive 16 inaenda juu. This is 0 kwa sababu imepanda, hiyo itakuwa hapa juu. Hii ni inaenda chini, so itakutoka hapo ikuje chini. So the nature is going to be this. Then this point, it means that 328 is the maximum point. And that is how you will get your 10 marks. Thank you very much. So, application of differentiation in calculation of velocity and acceleration. There are terms here now we need to understand. We have the term we call displacement. Displacement is represented by S. Then we have velocity. Velocity, we use V for velocity. And then acceleration, we use R for acceleration. Where you see T, T stands for time. So the application of differentiation in calculating velocity acceleration is what we call kinematics. That is what is called kinematics. For example, when we have S is equal to 20t square plus 4t minus 8, this is what we call displacement. Displacement is the same as the distance. So if a particle is moving, it displaces it moves a certain distance, and that distance is what is called displacement. So displacement is the same as distance, but here we use displacement S to represent distance. If you have distance, if you have displacement, to get velocity, you differentiate once. So this displacement, velocity, and then acceleration. So if you have displacement, to get velocity, you differentiate. To get acceleration, you differentiate velocity. So here you differentiate down. You differentiate. You differentiate to get velocity. You differentiate velocity to get acceleration. You differentiate velocity to get acceleration. So let us look at this one. So here velocity is equal to ds over dt, because this is s and this is t, which is equal to 40 t, right, plus 4. That is velocity. So if I want acceleration, acceleration A is equal to the differentiation of velocity, which is now dv over dt. Excuse me. Now this one is the same as, now you differentiate this, this is power 1, so that is 40. So it means acceleration is 40 only, right? Another thing is to know to write the units, right? So the units for displacement is in meters. Displacement is in meters. Velocity is in meters per second. And then acceleration is meters per second square. Meters per second square. So it is important to know the units. Now let's go and look at an example, and then we will finish this topic. A particle moves on a straight line, moves along a straight line, such that its displacement, you have been given displacement, is s is equal to that, where t is equal to time in seconds. Find A, the displacement of the particle at t is equal to 5. That one is simple. If we have displacement and we have time is 5 seconds, then we just substitute to the equation and get the, let me use this equation for the other page so fast. So our equation, so let me go to the new page. So our s is equal to t cube minus 5t square plus 3t plus 4. But we have told to find the s displacement when t is equal to 5. So you simply say ts will be 5 cube minus 5 square, which is t, plus 3 times 5 plus 4. And that one will give us the distance. The distance or the displacement. You will realize that that one is going to be 29 meters. So that one will be 29 meters. So here it will be 29 meters. Find the velocity of the particle when time is equal to 5. So to get the velocity, I have said you differentiate displacement. That is s. So next we get, that is A, we have finished B. Velocity is equal to ds over dt. So that one will be 3t square minus 10t plus 3 plus 3. That is what we have as velocity. So velocity, this is our velocity. But when we were going to find the velocity when t is equal to 5, you just substitute here and get the velocity. So velocity is equal to 5 square minus 5 plus 3, and that one will give us 28 meters per second. 28 meters per second. And that is it. Now C, the question C says, find the time when the particle is momentarily at rest. That is the key word. Find the time when the particle is momentarily at rest. A particle is momentarily, mark that, at rest when velocity is equal to 0. Mark that place. A particle even a moving vehicle is momentarily at the time is zero when the if the velocity is zero, inamaanisha imeenda speed. Velocity ni speed. Speed imesimama. Kari ikisimama, what will be the time? Zero. So the time is momentarily sorry, not the time, I'm zero. I mean when an object, when even a vehicle is momentarily at rest, velocity is zero. The speed is zero because it resting imesimama. It has stopped moving, so velocity is zero. Very nice. So to tackle C, you need to know at rest, a particle velocity is equal to zero. Now you come here and look at our velocity. Our velocity was 3t squared, so you copy that. So velocity is equal to 3t squared, 3t squared minus 10t plus 3. So you need to equate this one is equal to 0. So that's what it means is that now you need to solve to find the time when that. Now this one you are going to use the quadratic formula in form 3, first topic. You use quadratic, that is the most important. We know, so t is going to be minus b plus or minus the square root of b square minus 4ac over 2a. So that is the quadratic formula which will give you the answer there. You can as well simplify using the factor method in form 2, which is also very simple. So I can use also, I can say I can simplify this using the factor method in form 2. So you will find finally that the time, so you will solve and then you will find that the t is equal to 1 over 3 or t is equal to 3. So the time will be 3 seconds or 1 over 3 seconds. That is the time when the velocity will be 0. When the object, when the vehicle is momentarily at rest, velocity is equal to 0. Remember that. Number D. I did not finish writing the question. Oh, okay. I didn't finish writing the question. The acceleration when the particle, dividing the acceleration when the particle of the particle, sorry, the acceleration of the particle when t is equal to 2 seconds. So we need to get acceleration. How do you get acceleration from here? Acceleration is equal, you differentiate velocity. Acceleration is equal differentiation of velocity. So we go back here. We have our velocity here. To get acceleration, we just differentiate velocity of velocity is equal to 3 squared minus 10t plus 3. Therefore, acceleration is equal to dv over dt is equal to dv over dt. And this one will be 6t minus 10. That is the differentiation of v. But at when t is equal to 2, then a will be 6 into 2 minus 10. And this one will be 12 minus 10. And this one will be 2 meters per second square. Because velocity, acceleration is written in meters per second square. Very important. Maybe I do one more last example on the same. The displacement s in meters. Last example, we finish. The displacement s in meters covered by a moving particle after t seconds is given by s is equal to 2t cubed plus 4t square minus 8t plus 3. Find velocity at Roman 1 t is equal to 2 seconds. Wacha nitumie moja, kuna cha kujirudia. At t is equal to 2 seconds. So let us start number A and finish it with it. Allah, what's wrong with this thing? Allah. Sorry, these things gives me sometimes hard time. So solution. So we want velocity at t when t is equal to 2 seconds. So velocity is equal to ds over dt. So let us differentiate this one. Itakuwa 6t square plus 8t minus 8. So when at t is equal to 2, you substitute here, itakuwa 12 into 2 square plus 8 times 2 minus 8. So in 4, itakuwa 4 times 48. 48 minus plus 8, itakuwa 56. 56. No, itakuwa 24. Yeah, this is kwa nini nimetoa wapi? Ni 6. So itakuwa 24 plus 8, which is 32. So this one will be 32 meters per second, because hiyo ni speed, ni velocity. Part B, the instant at which the particle is at rest. B, find the instant at which the particle is at rest. Remember, a particle is at rest when velocity is equal to 0. So we have velocity. So V is equal to 6t square plus 8t minus 8. This one is equal to 0. So the instant is giving us the time when the velocity is going to be 0. That is what it means. The instant when the particle is at rest, you solve that one. So you solve this using quadratic formula, and you will find that t is equal to 2/3 seconds, or t is equal to -2. So you realize that it is not going to be possible for time to be negative. So a negative time, when you calculate the time and you find the answer is negative, ignore that. So the answer is the instant at which the particle is at rest, time will be equal to 2/3 seconds. This one ignore, because there's no way a particle can be, or time can be negative. Thank you.